Yeah. So my name is Attila Marosi. I work for Sophos, the Sophos Labs. First of all, I would like to say thank you for the organizers. This is my third time in DeepSec, so that's not a coincidence. I like this conference so much, and I'm very happy to be here again. So the presentation will be about HackingTeam and their Android stuff. What kind of things they use to infect the Android device of the target persons. So the agenda. First, just a couple of things about HackingTeam. I think there is no need to be introduced about this company and this phenomenon because they are very popular, and the things what happened with the company cause so much fun for the IT security guys. Then the leak, what happened with the company, the Webview exploit, how it's worked and how they delivered the exploit. There will be some demo, and after that there will be a couple of things about how they flow under the radar, because the security companies and the guys who wanted to hack this company and their product know this phenomenon and stuff many years, but they didn't reach a good point and a good analysis at all, so they had to be hacked to get all the things about it. So they have very good techniques to flew under the radar, so it's interesting to discuss. So first of all, HackingTeam. So it's a company who provides law enforcement products, so products for law enforcement agencies only. Their flagship was the remote control system, which was implemented all the interesting operation systems and mobile devices. So they were able to monitoring the most of the gadgets we use. To deliver the malware and to install it, they used remote exploits as well, and they used agents locally to install the software in human activities. They developed BIOS rootkit to stay and be controlled over the device after reinstall or detecting the things. So they have this technology as well. And what was the best point of them, because they are law enforcement or because they have support in law enforcement agencies, they have the ability to inject and send their exploits in ISP side. So most of the hackers doesn't have this ability, so they do not control the ISP side, so they need something else. But if you are in that side, you can deliver your exploit much convenient, and you can have other technologies like melting stuff they use. So the company gets the enemy of internet stamp because they sold their product to companies, to countries which use this product against journalists and protesters, so not traditional criminals. So they were attacked, and I think that was the reason they were hacked by hacktivists. So that was the starting of the story when the company official Twitter page post. There was the tweet on Twitter that we released all our stuff, and after this couple of months, the community just bubbling about the stuff what was released in this huge amount dumb data. So it was 400 gigabytes of source code, email discussions, and everything they have was released, and it provides so much munitions for the security community to discuss. So after the release, many patch and many hotfix was released because there were, yeah, so that's the summarized. There were 6 0 days which was released in this dump data. All their stuff was stolen. The company said that their most precious data are still protected, but maybe it's just a promo message or something to keep their customers close. In the dump data, there was release brochures, documentation, so now we have all the information about the things they used. I think just about the release and the stuff they stolen, that's now I think that's the entry point for criminals. If they would like to produce malware, which is very tough and could be very difficult to detect, they just seek over this source code, this documentation. So it's a very good knowledge they summarized. So we can expect that criminals will learn about this, and they will use these methods, these technologies, and this source code which was released. So for other various writers or something, evil guys, it's a very good munition. So it's very good for security guys to analyze it and to get more knowledge about a company like this, and it's a very good munitions for criminals to get new techniques and to get new knowledge about how to be very good in this field. What was very interesting, according to emails, how they buy 0 days. There is a very good article about it, how they bought the 0 days they used in their product. I think it's worth to read because it's a gray area. There is no much knowledge about how the 0 days are sold and how you can buy it, what happened if they patched. So it's something which is rare, so I think it's worth to read. So the infrastructure was very simple, how they control the device. There was an agent which has implemented all the interesting platforms. The infection part was the interesting part of it. I think they had many ways to infect and to install the agent on the device they would like to. So melting stuff was implemented for all the platforms, so PA, exe file, and AP keys, and all the others. Melting stuff was able to split in species the executables and put the agent in the executable and repack again. So it's infect on the fly. So they implemented in ISP proxies. So when you click on, for example, Total Commander to get the newest version of it, and it wasn't signed by digitally, they were able to put something to the exe on the fly, and you get the modified the modified Total Commander to install. So it's make it very easy to infect your machine. So, and the control panel is traditionally a very fancy control panel for agents to send command and to receive the collecting evidence from the device. How they deliver the exploit? Because they don't want to infect the whole world. They have target persons. They have to shoot very, very accurate. So not spreading the link which spreading the exploit. They have to shut. Mostly they were just one-shot exploits. They were send it and check it worked or not, and if it didn't work, they tried some different way or something. So it was a one-shot exploits traditionally. So the techniques they used was very simple. It was just a PHP file which handled the request, and they combined it with an ini file which was able to manage the things which is described here. So the entry point was always the FWD, so a sample URL, something like this. That was the ID of the infection. That's the entry point, and that's the other side of the exploit. So it's randomly generated. So when you request this URL, the PHP site seeking for the static or dynamic part of it and serve the request. If you call this one, the other part of the exploits get 5 minutes to be request. So that was the only way you can reach the exploit. If you try it in different way, or you just get the half of it or something, you won't be able to get the whole exploit again. So the best way to get the whole exploit in the right way, to have a network flow and make the analysis in that way. So it makes much difficult to analyze the exploit process. They filter the request and process it dynamically. Here is an ini file. So as you can see, there is only 2 hits. So this URL can be called just 2 times. That's the expiration. So it's a very short time when you can call it, only 2 times. This is the only agent type which can call it. And if it's valid, the other part of the exploits get 5 minutes to serve, and the exploits could be delivered. Otherwise, it's redirect you something else. So the exploits won't be disclosure. So the agent they installed in Android devices. They developed a custom shoe root toolkit for their applications. So the old name was RealCap, the new name is DDF, and it was very richful and it was very easy to manage the device with root access, and it was difficult to detect that your phone is already rooted. So normal root detection application won't be able to detect that your phone is rooted. So it was able to modify the permissions of the AP keys. The interesting part of this application, they used the media service system, and they hooked into the media service system to get all the audio input and output from the hardware part of it. So it doesn't matter that you used Skype or Viber or something else. It's not interesting. They get the source, input and output at a deeper level. So it was very easy to monitoring discussion in a room, for example, because the microwave was also active, or just intercept all type of calls. And traditional evidence gathering features, screenshots, clipboard monitoring, location tracking, and they parsed all the databases of the interesting communication applications, so they get all the information from that part. So the DDF root tool was very, very easy to use. It has some parameters, and they just called, for example, QZX, and then the command they would like to execute as a root, or get a root shell with this one, or add an application as an administrator application, or modify, seek for content in files, regardless you have access for the file or not, because they have root access. So it's make it much easier to use the root power on the device. So how the exploits looks like in this platform? They used an exploit against Webview. Webview is not now, but previously was a part of the operation system, so it's part of the Android system. Their exploit works on 4.0 until to 4.3. In this time, the Android was equipped with a WebKit, when 3 vulnerables were in that WebKit, and they joined the 3 vulnerables to create and get a code execution on the device. So it's a very sophisticated exploit. This exploit has 5 stages to get the code execution, and then they download some other stuff to download other stuff. So it's a little bit complicated, but they were lucky because one of the weaknesses was an information leak, so they were able to bypass the ASLR, and then they used 3 others to manage the code execution. For local exploits and to get root access, they used known exploits, so there is no new things in that part. But because Android's device typically very rarely updated and firmware changed, it could be worked on many devices. So that's the 3 vulnerabilities they used, and they combined together to get the code execution. So information was used to bypass the ASLR, memory read to get the libweb core point of the memory, and buffer overflow to write the payload in a right place. If you check it, as you can see, it all belongs to Chrome. So it's not an Android stuff, it's a Chrome stuff. Just the Chrome WebKit was ported into Android, and that was the chance for them to use these vulnerabilities. So these are not Android vulnerabilities; these are Chrome vulnerabilities. So this graph is this September. So it's not so old, and still more than 35% of the used devices currently are vulnerable against this Webview exploit. And as you can see, the 4.0 until the 4.3, the Webview, when the 3 vulnerabilities there. So these Androids equipped with this WebKit. So that's the problem. The latest Android has Webview with a different engine, and it's delivered as an AP key, so it could be very frequently updated. So it could be not a serious problem in the future than previously, because if a component is vulnerable and there are exploits against it, and it's into the firmware, you can update the whole Android and to patch the vulnerabilities. So it makes much difficult. That's the problem with the old Android devices. So this is the device they focused on with their exploits, local to root and remote to root. So that means the Webview working there, and local to root means that the three root exploits working on these devices. So the company focused on these devices, but it could be worked on many more, but they haven't tested. But it's many. So Samsung devices cover the largest part of Android devices. So how the Webview exploit work? First, the Go HTML, it was able to check that the information leaked vulnerabilities there or not. If the device is not vulnerable, they're just pointing something else, the script, yes, is a 3,000 line code to manage the whole exploitation. According to the emails, it seems to be they bought this framework from Wupen, and they filled and changed the exploit in the file. So Wupen sold this framework. It's very funny that it's a framework. You can change the exploits you would like to change the vulnerabilities you would like to use for some purpose, but for managing the exploits, you have a very comfortable framework to use it. So it's very professional stuff. When they prepare the memory for exploitation, they use the memory read weaknesses to get the right information and to prepare and to create a malform and a well-crafted XML to use it with XSHLT and trigger the buffer overflow exploit. All the steps, they check back that they are in the right position, they have all the information and everything's work in a way they want it. Otherwise, they just terminated the things to not disclosure more part of the exploit. So when they reach this part, they check it, okay, everything seems to be nice, then download the other part of the exploit, and when the module was the first payload, it's a shared library, they write it into the memory, and when they prepare the final stage, they just call it with the right parameters, and the library just download the other part of the exploits, which was the exploit. It's very stupid that they call the exploit its exploit. I don't know why. So there was the exploit, that's the root exploits to gain root access, and the installer, which is a scout agent. It's just an application to check the device, collect information about the device, send back home to give information to the agent that they infect the right phone or not. They do this method, so they not install the fully equipped malware on a device at the first step. They just send a scout to get more information about the device they just hit, and when they confirm that, okay, we are in a right device, then they update the device for a more powerful stuff. So the installer is just a scout agent. Yeah, so the exploits is the exploits, and they this LF dropped the DDF into the system bin to provide the ability for the scout agent to get more access. So if you had the knowledge about just call the DDF with the right parameters, any application can use it with root access to get root access or something. So in stage 4, that's the last step. When they prepared everything, they copy and write everything, they just send this value back to the server. This is a memory value, and that's a check that everything's correct, send it back, and the response was the right ASCII to decrypt these 2 files. Otherwise, they provide something bullshit, and you won't be able to decrypt the 2 files. So let's demo. The first would be an email. I just send an email to the device, click on it, and trigger. But as HackingTeam also realized that for target person, it's not working. So they can send well-crafted emails and SMSs that it would be nice to click on it and next finish, install it. No, it's not working. So they use the ISP and other techniques to install their application using this exploit. So I would like to demo this version. When I use it's not a Wi-Fi. I use a VPN. Just imagine it's a Wi-Fi. It could be a Wi-Fi. So maybe I'm an ISP, or I just provide a free and a very flattering free Wi-Fi to join, or just using the DeepSec free Wi-Fi and hijack your connection. So there are many ways to get the flow in a shared network. And I just use the mid proxy to selecting the HTTP request. I know that which WebKit version is vulnerable, so I do not touch any of the not suitable HTTP request, so we have a right network connection. But when we get a right request with the right content, I just inject an iframe, and then the application will be installed through the exploit. Yeah. Oh, sorry. Yeah. So the demo. So that's my device. Yeah, it's going a little bit slow. Okay, and I have a server here. Yeah, there was some request. So I just open Index. It's a Hungarian news site. So it's working correctly, and if you check it, I'm a sad panda because this agent, this WebKit, yeah, it's a newer one, because the Chrome, if you install the Chrome or use the latest version, which is in fact involved with this exploit, the 4.3, it's original equipped with Chrome, and this has its own WebKit. It's delivered an own WebKit, so this application is not vulnerable. But what if I use an application which use and use the WebKit I would like to attack? So Android applications very often use Webview because it's a very powerful tool to display content. You just put it to the display and provide some HTML part. It's very easy to manage, much easier than create Android layouts and buttons. It's complicated. Just put a web view and provide a web page, and everything will be fine. So this application installed more than 100 million devices, so it's not a popular one, but it doesn't matter because the WebKit is used very frequently. If I click on images, we will recognize that this request was good for us because the operation system provides a WebKit, and this WebKit is vulnerable, so I can inject an iframe. And if you check the exploit server, as you can see the logs, here we send the goal, the script, that's the crafted XML, that's the module which downloads the other parts. And as you can see, the key was correct for us, and this is the exploit and the installer. So the payload worked well, download the exploits, the root exploit, and the installer. The installer is my test application, so not the HackingTeam one. It's a very dummy application. It was created by Android Studio as Nexus Finish, so it's not a featureful stuff. It has many sleeps and things, so it makes times to get the new application on our device, but it will, yeah. So I just continue, and we will see that the install was correct. So yeah, how they flew under the radar. Because all the source code released, we know that they obfuscated all static data in their code in coding stage. So they just obfuscating everything before the build, and then they build it and they pack it, and then they use the commercial tools to protect it. So they use multi-levels to make it much painful to get the data and to code back. So it was very tough to reverse engineer the things. The melting, as I mentioned, that they were able to meld the things together, which makes their application less suspicious because you just download something and install it, and there were no need to provide new application, just infect something. And as I mentioned, that they use the Scout, Elite, and Soldier, different version and different featureful version of the application, not disclosure all the things they use. So they increase the level when they know that, okay, we are in the right position, that's the device we would like to infect it. There is no application on the device which is backlisted, which could cause an alert or something we haven't handled or something. So they protect their stuff. And for example, if a Proxmon or something running on your system, they just go back, okay, it's too risky. Maybe next time, or maybe something else would be nice for it, but not risking the full code of it, because it could cause losing the product. So for example, the dropper has antivirus, anti-VM detections with VME queries to get information, and they were able to configure that this agent although to run on a virtual machine or not. So they can. So that was the chance to test it, because they test it in virtual machine, so they have to configure it. So they have cuckoo avoiding techniques. They used a trap for Cuckoo DLL. that they put a very big value in FS44, and then they call the sleep, which was hooked by cuckoo with 1 minute. And when they call it, it's called a crash, and the application just stopped, and the report was empty. If they reach that part, that means that cuckoo there is no cuckoo there, so they can continue the execution. For Android devices, they use these techniques to get the information about it's the emulator, for example. So emulator has this static value if you not change it, or for example, the CPU file does not exist on emulator. So with this, they can check it which device they are running. And for me, the most interesting part, they had a dedicated cluster, dedicated VMs for separating antivirus product, and they always monitoring their application against all the antiviruses and checking and puppeting the application that maybe it's cause alert or not. They have a full environment. And for example, you can use it out of the box, and if you are developing malwares, it's a very powerful stuff, because if you would like to develop something like this, it's time consuming. But now everyone has these tools, everyone has this knowledge, so I think it's increasing the level of the entry point of creating malwares. So it was a QA process for them. That as you can see, it's a very big cluster. The most of the non-antivirus systems are there, and they have an agent, and they just puppeting their agent that, okay, collect all the emails from that number to that. And maybe it's cause something which give an alert, one of or more of it. Maybe it will be silent, or just start a keylog and just monitoring that is there an alert somewhere or not. So it's a very powerful tool if you would like to bypass antivirus systems. Yeah. So conclusion. I think they do their job in a right way, but they have clever enemies or something, so their stuff never reverse engineered fully. They combine the protecting solutions in a right way, and they have a very, if you compare it, for example, Zbot or other big families, they threatening very few people, so that could be good protection, that not spreading your malware, just pointing to your target. So this also protects their product. But I think it was well designed, and they use the techniques very cleverly. The Webview, as you know, and I didn't show the installed application. So that's the evil application I installed. So with hijacking the network flow, I can install this very stupid application on the device. So yeah, this exploit could be used to install something on a device, but which is, I think, much scary, that you don't have to deliver a root exploit to install something. If there is an application, for example, a password protector, and you can gain a code execution in the name of the password protector because they have Webview, and you can hijack an unencrypted traffic, you can loot the application and you can get the value without pawning the full Android device, and you get the precious stuff from them and just let the device alone. No one knows that you pawn the device, you stole the things, because it's just in a memory. When you kill the application, everything will be gone. So it's very scary. And for example, this is the most popular password protector application, if I find it. Yeah, Keeper. And for example, if you use the Keeper in a way like this, and you have a link like this, and HTTP, and there is no S, and you click on it, you can use the Keeper to display the page, and you will be able to hijack this connection as well. And you can, yeah, here, and you can execute the exploit in a name and the context of the Keeper, so you can loot the application. So this exploit is freely available. Criminals can be using it without any investment, so it's very cheap. Just set up a free Wi-Fi, and if you have a chance, just hit the Webview exploit, loot the application. It doesn't matter which application, and you can select the gathered value. It's very difficult to get information about it, and the most of the product in Android do not have the chance to get that flow, because the applications are separated, so you do not know that that application was pawned or not, if you don't want to touch the other part of the phone. So, okay, it's not for all Android, it's that part, but it's still more than 35% of the device, so, yeah.